So good day to you, sir. Today I'll be presenting the lab activity, which is the modular media suite. It is a I I made a Java-based design, which is designed to simulate a flexible and extensible media player. The goal of the system is to show how different media components like sources, plugins, and playlists can be modularized to support various media inputs and runtime features. The modular media suite supports three main ideas, which is the multiple media sources, the which has the local files, HLS streams, and remote APIs. Plugin architecture have add-ons like subtitles, equalizers, and watermarking. Composite playlists are playlists that can combine multiple types of media. All these are organized under packages such as playlist, plugin, and source, which makes the architecture easy and is easy to extend and maintain. So the code structure information. So at the left, we can see that all these are organized under, uh, let's take a look at the left. Under playlist package, which is this, has composite playlist, which handles playlists that contain subplaylists or multiple media types. Then is media file item.java and playlist item Java, which represents individual media items. Under plugin, we have subtitle plugin.java, equalizer plugin.java, and watermark plugin.java. This for here. These are modular enhancements that can be applied to the media stream. Under source, there are classes like file local source Java, HILS source.java, and remote API source, each representing a different type of media source. And proxy caching simulates splitting media into chunks for playback. All of these are together under the main Java classes. The main Java class, which coordinates everything when the system is executed. So, what happens when it runs? So, this shows up. So, at the first half, it shows registered plugin, which is the subtitle plugin, equalizer, and the watermark. After that, the program begins playback and announces starting playback with software rendering. This means it's using simulated software render to process each video chunk. It then plays a composite playlist, for example, Mixed Media Demo, which contains a local video that and a cached HLS stream. So the playback details and the playback details or software rendering. In the terminal output, you can see messages like local video, this local playing local video source, local video sample.mp4, and this software rendering chunks local chunk 1 with subtitles, equalizer applied, and watermark. Each line represents a simulated media segment being processed. Every chunk goes through the pipeline, which is this. The subtitles are added, equalizer effects are applied, and watermark is embedded. This shows plugin chaining, where multiple independent modules are applied in sequence to enhance the playback. Then the system plays a cached HLS stream, showing how it can stream content from the internet. So this proxy cache HLS HTTPS example that stream UI. This is the streamed content from the internet. So next is the hardware renderer. you can see that the system switches to hardware accelerated rendering, meaning the rendering strategy was changed at runtime for better performance. Now, the render tag says hardware rendering OF. It repeats the same enhancement pipeline, which is the subtitles equalizer and watermark, but this time rendering is faster and more optimized. Then the system plays another composite playlist called Remote API Group, which demonstrates external integration. This part simulates fetching and streaming media data from remote APIs, which are ideal for services like YouTube, Spotify, and other live video APIs. To summarize, the modular media suite shows how to build an extensible and maintainable media system using object-oriented design and design patterns. This design allows the new features like new plugins or source types to be added easily without changing the core of the code base. And that concludes my walkthrough of the modular media suite, showing how it's structured, how it executes, and how it demonstrates modular Java architecture in action. Thank you. So good day, everyone. So good day, sir. So this is the UML class diagram for the modular media streaming suite, which is a refactor design of a media player system. The main goal of this system is to make it modular, extensible, and flexible enough to support different media sources, plugins, composite playlists, and rendering strategies. The diagram is organized into 4 main packages: player components, media sources, playlist management, and plugin system. I'll explain each package and how they connect with each other. So the first component is the player components, the first one is the player components. The player components package is the core of the system. At the center, we have the media player class, which is this, which controls the playback process. It has 2 main relationships. It uses render strategy, and it has a plugin manager. The render strategy interface defines how media chunks are rendered. There are 2 concrete implementations. First is the software render for CPU-based rendering, and there's a hardware render for GPU accelerated rendering. This demonstrates the strategy pattern. This is the UML, allowing the player to switch rendering strategies at the modular media without modifying the player code. This plugin manager manages the list of plugins and applies them to the refactor design of a media player ensures system. That the main goal of this system features like subtitles or equalizers can be added dynamically to support different. This makes the system extensible without modifying and rendering core logic. Next is the diagram is organized into 4 main packages. Media sources, player components, media sources defines how the media player retrieves data. I'll explain each package and how they connect with each other. So the first media source interface, which exposes 2 methods. The first one is the ID components. The player component identify the source components package is the core of the system. Media chunk center. Concrete implementations include the media player class, which is this, which controls local the file source for local video files. It has 2 main relationships: HIS source, render strategy for online HLS streams, and it has the plugin manager API source for media fetched from web APIs. The render there's also a proxy catching source how media another chunks are rendered catching VAR. There are 2 concrete. This uses the decorator pattern, allowing the software render catching to be added CPU without altering the base source classes. There's a hardware render for GPU accelerated rendering. All these sources produce stream chunks. This demonstrates the strategy small pieces of data representing portions, allowing the player to switch rendering strategies at runtime without modifying the playlist management. This plugin manager management package organizes multiple applies items to the stream chunks. It's built around a composite pattern. Features like subtitles or equalizers can be added. List item interface. This makes the system extensible without modifying the playlist layers. We have 2 concrete types. Next is the media sources. The media sources field item, which package defines how the media files data, and composite playlist from which encode multiple playlist items, either individual files or the media source interface, which exposes. This allows users to create the ID playlist or composite to identify the source, where one playlist is to contain others. The media player can concrete implementations include using play composite and play item methods. This design file source for this design increases flexibility, enabling complex HIS source sequences without complicating for online HLS streams. So the next is the plugin system. for
We
media
have the
fetch
plugin
from
system
web
package,
APIs,
which implements another extensibility.
There's also a proxy catching source which decorates another
mechanism
media
using
source
the
catching
plugin
behavior.
pattern. This uses decorator
At its
pattern,
center,
allowing
the player
catching
plugin
to be added
interface, which
without
defines
altering
two
the
methods
base
such as
source
the
classes.
name to identify the plugin and process.
All these
is
sources produce
to modify
objects.
a stream
Small
chunk
pieces
before
of
rendering.
data representing portions
There's also
of
three
the
concrete
stream.
plugin implementations.
Third
which
is the playlist management.
Subtle
The playlist
plugin
management package
equalizes
recognizes
plugin
how
and watermark
multiple
plugin.
media items are handled.
So subtle plugin
It's built
overlays
around
text
a
subtitles
composite
on the
pattern.
video.
The
Equalizer
pattern play
adjusts the audio frequencies.
list
Watermark
item
adds a
interface
watermark to the video
represents
represents a generic item.
These
in the
plugins
playlist.
are managed
We have two
dynamically by
concrete
the
types.
plugin manager, which applies all registered plugins.
Media field
sequentially
item,
to
which
each media
represents
chunk during
a
playback.
single media file, and
This makes
composite
the
playlist,
player
which can hold
customizable
multiple
and
playlists
supports
on the fly,
feature
either
loading.
individual files or sub-playlists.
So this
allows users
UML
to
diagram
create
integrates
nested
several structural
playlists
design
or
patterns,
composite lists,
strategy patterns
where one
for
playlist
switching
can
and
contain
rendering
others.
strategies.
The media
The
player
creative
can
pattern for
recursively
adding
play
caching
caching
behaviors
to
play
media
composite
sources
and play item methods.
Composite
This
pattern
design
for
is
nested
this
playlists
design increases
and
flexibility, enabling complex playback
plugin patterns
sequences
for flexible
without
media
complicating the player's enhancements.
These patterns make the
So
system
the
maintainable,
next is the plugin
modular, and
system.
scalable.
We
Solving
have the
problem
plugin system
for
package,
the monolithic
which implements another
legacy code.
extensibility. Thank you, and this
Mechanism
mechanism
using
using the
explanation
plugin
for the
pattern.
UML diagram.
At its center, the player plugin interface, which defines two methods, which is the name to identify the plugin and the process is to modify a stream chunk before rendering. There's also three concrete plugin implementations, which is subtle plugin, equalize plugin, and watermark plugin. So subtle plugin overlays text subtitles on the video, equalizer adjusts the audio frequencies, and watermark adds a watermark to the video frame. These plugins are managed dynamically by the plugin manager, which applies all registered plugins sequentially to each media chunk during playback. This makes the player customizable and supports on-the-fly feature loading. So this UML diagram integrates several structural design patterns, strategy patterns for switching and rendering strategies, decorator pattern for adding caching behaviors to media sources, composite pattern for nested playlists, and plugin patterns for flexible media enhancements. These patterns make the system maintainable, modular, and scalable, solving the problem for the monolithic legacy code. Thank you, and this concludes the explanation for the UML diagram.